our learning target for today, and it is the, what, 8th?
Yes.
Says, I can simplify rational exponents. Kind of. So rational exponents are when you have a fraction as your exponent. So we've had positive numbers, we've had negative numbers, we've added, we've subtracted, we've multiplied. Now we're going to talk about what happens when we have fractions as exponents. You do not divide, even though that would be the last operation that we have, correct? Does anybody think they know what to do on these? I don't know if you learned this last year or not. You turn it into a radical. So your 2 travels and it goes right here, or whatever your denominator is, and your 1 travels and it goes out front. Now, since this is called a square root, you don't have to write your 2, and since our numerator is 1, you don't have to write the 1. This little hook thing means that the radical ends. That's it. That's all you do. And then you simplify it, which we're going to use our perfect squares to do that today. So rational exponents become radical. Let's write that over here. So, for example, if I wrote a to the 2/3 power, sure. Are you going to build one or are you just going to draw one? So it's going to be boring if you draw it. Same thing with your pencil pouch. Alright, so these become radicals. Which is going to go in the front of our mullet? That's what we call this thing. This is a mullet. The 3. Alright, the a goes under here, and then you put the 2 on the outside. So it's the cubed root of a quantity squared. Ta-da! Isn't it magic? Now, if I had, for example, 3x to the 3/4 power. Now, written like that, is that 3/4 on the x or is it on the 3? It's only on the x. So we're going to put that 3 out front of the mullet. Well, let's call it a radical. Let's use real terms. And what's going to go in the mullet thingy right here? The 4. The denominator goes right there. What goes under the house? X. And what goes outside? 3. And today we're going to learn how to break this down. Yay! It's really easy. Are we ready to practice? Okay.
I don't know.
You said you thought of something. Yes, sir.
Is it a log equation like simple equation?
No.
Okay. Thank Jesus. Because my issue that I'd always just one thing.
No. No. Yes.
Can you do this?
How are you going to draw it?
I'll cook it.
But it's got to be scaled down.
Oh, never mind.
Okay, so let's go to 50. Let's go to 51A. Parts of is. Oh. sure. Every time she looks at it, she's like, it's boring, but okay.
I was gonna bake a cake. That's why I was thinking that sounds good. Mainly because I'm hungry.
Okay, anybody else need this foldable? We're good? Do you need this? Okay, then we're good. Alright, so this entire thing is called a radical. And what we're going to do is we're going to list the parts of a radical. Now, if I put A right here, and I'm going to put a cubed here, each of these parts has a special name. It's crazy. It's called an index. This other little number is called the index. Yes. Can you try not to sound like I'm killing you? Alright. Underneath this, you're going to do this is called a radicand. So the whole thing is called a radical. The thing under the house is called a radicand. The number that's inside the mullet is called the index. And this special bar up here is called a vinculum.
These are big people words.
Are you a tiny people?
I have a tiny brain.
Well, that's not what I asked.
You could be tiny and still have a big brain.
Or just be intelligent.
What's that
Yeah.
like? Trump skateboard.
Salisbury, did you know that Einstein's brain was slightly larger than ours?
I did not know that. That's a fun fact. Okay, so the A, anything under the house is called a radicand. The thing inside the mold is called an index. The top bar is called a vinculum. And the whole entire thing is called a radical. Whoa. Now, if the index, your little thing at the bottom, where it has some words, and it has a star, if the index is not written, it is automatically a 2. So if it's a 3, we say the cubed root. If it's a 2, we say the square root. Or if there's not one, we say the square root. If it's a 4, we say the 4th root, 5, the 5th root, etc., etc., etc. And each part does different things. Now, if it's a square root, the way you simplify it is you don't divide. You need 2 of the same number. If it's a cubed root, how many of the same number are you going to need to simplify? 3. If it's the 4th root, how many of the same number are you going to need? 4. And that's where our square roots and cube roots come in. It's magic. Bless you. All right, now go to the next page so that we can practice. Now, we are not going to do the cube roots, or we may do the ones with the numbers because we're pretty P and we can. But let's start with all of the ones that have a square root. So the first one is the square root of 24. What you do is you find the biggest perfect square that goes into that. Now, what is a perfect square? Something multiplied by itself. Like 2 times 2 would give you, so that's a perfect square. Is 1 a perfect square? Yes, because 1 times 1 is 1. So let's list our perfect squares at the top, just in case we're crazies and don't remember. Alright, so 1 is a perfect square. Which one comes next? 2 is not a perfect square. The square root of 2 is not a whole number. 4. And then 3 times 3 is 9. And then 49. And then, look at you go, take a point. And then 100. Can anybody tell me 11 times 11? 121. 12 times 12. 13 times 13. 14 times 14. 196. Good, take a point. 15 times 15. 225. 16 times 16. 17 times 17. 18 times 18. 19 times 19. 20 times 20. 400. Look at you go, killing it on that one. Take a point. I'm pretty sure we made a perfect square card at the beginning of the year, didn't we? Yeah. So you're going to need that for this. If you still know where yours is. If you don't know where it is, you can make a new one.
It's like all kind of worn and it looks ancient, like an ancient piece of paper.
I'm sorry, I took way too big of a bite with the teaching.
You know how I said that I have memory problems? I think just now I realized that I, like, pretty sure I forgot to wash the conditioner out of my hair.
Fun. Okay, so now what you do with each radical, this says determine the index and the radicand. We're going to have two parts. I'm sorry, I took way too big of a bite. Yes. Alright, so over here, we're going to identify the index and radicand. Over here, we're going to simplify. So what is the index of this problem? 2. Because our notes say if it's not written, it's automatically a 2. And what's the radicand? 24. Does everybody understand what we're doing now? Okay. What is your index here? And what is your radicand? 128 n to the 8th. Do you think you could do that for the rest of them without me? Okay. You want to do one more together just to be safe? Okay, what's your index of the next one? 3. And your radicand? 16xy. Okay, can you just check yours against mine, weirdos? Did we get it right? Look at us go. And the last one that you can't see down here, my index is 3, my radicand is negative 162. Okay, so now what you do to break it down, which is what we're going to do on this side, and we're only going to do the ones with square roots today. So the square root of 24. The first thing you do is you find the biggest perfect square that divides into 24. And it has to divide evenly. So looking at our list at the top, we know we're not going to go above 16, correct? Because those are giant numbers. Now, which of these perfect squares do you think divides into 24? 4. And you get 4 and what? 6. Because we're dividing. Thank you, Michael, for being able to divide. Take a point. From here, you take the square root of your perfect square. So what's the square root of 4? 2. And it's root 6. I'm going to show you again. I just need you to write it down and pause. Like, dear God. Now, the point of this is to get 2 of the same number. Correct? Yeah. So if you take the square root of something, you try to get a perfect square. The reason is, if you break down a perfect square, what is this? What is 4? 2 times 2. How many 2's do we have? 2. So one of them comes to the outside. When you have a number by himself, he stays in the house to read Harry Potter. And this is your final answer. So 2 of them go outside to play. 1 of them stays inside to read Harry Potter. You do that every single time. Are we ready to look at 512? We're going to do 512, not 512x squared. We're going to come back to that in a minute. You ready? Yeah. Okay. So, find the biggest perfect square that divides into 512. Now, you have to actually use your calculator and divide. So, you have your list that we wrote down at the top. Take 512, divide it by perfect squares. Let's not shout it out and give everybody a second, and let's see which one we get.
we have to do different parts above it too? So like leg, back of the chair.
The seat of the chair, how you're going to shrink it so that it all fits.
All 4 legs of it on it? All 4 legs. No. So just do one.
Those are all even. You got 4 is the biggest?
Oh, that's 15 out of 10.
I got
I can't read my own handwriting.
64.
64? What'd you get when you did 512 divided by 64?
Uh,
Look at you. Oh, go bigger. Because there's a perfect square in 8.
oh yeah.
So it's bigger than 16. It's bigger than 64. You got to find the biggest perfect square. $256. Look at you killing it. Great job. Take a point. And what is 512 divided by 256? 2. Now, if we take the square root of 256, what does that give us? 16 and 16, correct? And we need 2 of the same number. Now, are those 2 numbers going to stay inside to read Harry Potter or go outside to play? All right, who stays inside to read Harry Potter? The 2. And you're done. That's all you do. All right, are we ready to look at the one with 512x squared? It's super easy. Now, we know that for 512 we get 256, right? We get 256 and 2. Now, if you need 2 of the same number to be able to take the square root, how many x's do we have in x squared? You have 2. So is one of them going to go outside? Remember, you need 2 of the same number. So do you have 2 x's?
Yes.
Yep. So if this is a 2, what you do is you have 2, you take 1 out. Does everybody understand? Okay, look. X, X. How many x's do we have? 2. So one of them goes outside with our 16. And then the 2 stays inside. That's it. That's all you do. Or you do 2 divided by 2 is 1, so it comes outside. If it was a 4 right here, how many x's would come outside? 2. If it was a 6, how many x's would come outside? If it was a 5, how many x's would come outside? Well, let's see. If we have 5, if we have x to the 5th, right? So you need 1, 2, 3, 4, 5. You need 2 of the same number. So you have 2 of the same number, 2 of the same number. This guy stays inside. So how many x's go outside? No, you pick 1 from each of these, remember? So it would be x squared, 1 left inside. It's just like if you have 16, 16, 16. Oh, that one didn't write. You have 2 of the same number, so these 2 come outside. What does this guy do? Stays inside. Same concept. Let's look at 98k. So you have the square root of 98k. What is the biggest perfect square that divides into 98? 49. And what's 98 divided by 49? 2. Okay. So we have 49 and 2. What does 49 get broken down into? 7 and 7. All right, we have 2 7s, so they go outside. How many k's do we have? So he stays inside with the 2 to read Harry Potter. Okay, get your homework sheet. Did I not grab one? Please, do you mind? Thank you. I thought I grabbed one. Apparently not. What is happening? Okay, there are 41 radicals between 0 and 100 that can be written in simplest radical form. So this is the form that we've been doing, simplest radical form. Do not take the square root and get a decimal. I will not give you credit. Does everybody understand? Yes. Okay, now first, what's the square root of 0?
2.
What?
And you were so confident. What is the square root of 1? What is the square root of 4?
2.
What is the square root of 8? Ooh, that's not a whole number, is it? So what's the biggest perfect square that goes into 8? 4 and 2. Okay. If you take the square root of 4, what do you get? So it's 2 root 2. Does everybody see how I got 2 root 2? Because all I did was take the square root of my perfect square and brought it to the outside. Alright, what's the square root of 9? Okay. What's the square root of 12? We don't have one. So what do? 4 and 3. Alright, what's the square root of 4?
2.
And does 3 stay inside the house?
Yes.
Does everybody see what we're doing now?
Yes.
Ready, set, go. You've got plenty of time that you should be able to finish this and not have homework.
I've got